Hello everyone, hope you're doing well. Welcome back to my channel. Today we're at day 15 of the January daily LeetCode challenge. And before beginning with this question, first of all, a big congratulations to all those who have completed the first 14 days. That is the first 2 weeks of January daily LeetCode challenge. It was not an easy journey. There were some very good questions at the same, like we had some different topics, some unique topics I will say, like try and other stuffs. These are like something unique. This you will not, get mostly in many contests. But yeah, here they even try to explore with those concepts, the concept of try, the prefix or suffix and all those stuff, right? We did a detailed analysis of all those questions, and finally we are entering a from today onwards we're entering a particular week, I can say, where we'll be having some good questions on the topic of bit manipulation. And today we are starting with the XOR. Okay, so previously we have seen multiple topics, and some of the most prominent ones were, I can say, string matching or try, that is the prefix you try, you can say. Okay, all those stuff. And finally now we are entering the week of XOR. Okay, so that, I mean, bit manipulation. And today, in the topic of bit manipulation, we have the topic of XOR. Okay, so it's a very very good question, and I am very proud to say that, see the solution that I have submitted, it is beating around 100% of the test cases. Okay, so you are going to get the most optimal solution possible. Okay, I am not sure like how LeetCode has given the solution, but yeah, the solution that I have designed, it is beating 100% of the test cases. So I don't have to see what others have done. Okay, so that's why I'm sharing the solution with you. So just go through the solution, and if you have any questions, please do comment. Okay, with this, let me start with today's question. I have collected a lot of materials to help you explain how these things works. I've collected some diagrams. I will be showing you in between the questions. Okay, that is right shift, left shift, and the end operation. Okay, bitwise end. So let us begin with today's question. It is 2429. Minimize XOR. Okay, if you see, first of all, you will have to understand what is XOR operation. Okay, if you are not aware what is XOR, please just go and Google out what is XOR. I guess in yesterday, like 1 or 2 days back, we had a question XOR. Okay, I have explained in detail what is XOR. Okay, so please go and check that out. It's going to be really really helpful to you. Okay, as simple as that. Now, coming to the question, see this part. So if you see what we are given. Okay, one more thing is that in this particular question, I'll be also showing you, like, see, bit manipulation. Always remember one thing. So like, if you have started my video, I will just see this point. Okay, see, just get into this point, and then maybe if you don't like, you can stop the video. Okay, see this part. Always in bit manipulation, if you are required to decide, okay, how many bits are given. Okay, let us say we are given a number like this. You first of all should be calculating how many bits you are going to use. Okay, so in this video, like previously also, whenever a bit manipulation question came, I always include the number of bits that will be needed. Okay, so we should not use all the 32 bits. Okay, we only need a particular number of bits depending on the maximum input that we can have. Okay, so I've done those calculations also, and that is also something that I will be showing you today. Okay, so yep, let us start with today's question. Given two positive integers nums1 and nums2. Okay, find, that is number and num2, find the positive integer x such that x has same number of set bits as num2, and the value of x XOR num1 is minimal. Okay, let me quickly zoom in. Yep, is minimal. Okay, so there are 2 points. First is we have to find number x which is positive. What is that? X should be having the same number of set bits as nums2. Okay, num2, and the value of x XOR num1 is should be minimal. Okay, as simple as that. Note that XOR is the bitwise XOR operation. Okay, it has to be done in the bitwise way. That is, for each bit we will have to carry out this operation. Return the number of, that is represented in integer x. The test cases are generated in such a way that x is uniquely determined. The number of set bits of an integer is number of ones in the binary representation. Okay, so whenever you want to know how many set bits are there in particular, okay, number, just write the binary representation of it and count the number of ones. Okay, that is what we are also going to do. So this was the question. These two are the most important point. So first of all, what is XOR? See, XOR, it's something very, very, okay, simple. Okay, let me explain to the diagram. Let us say there are 2 bits. Okay, so any bit, okay, always it has only 2 values. So what are those values? Either it can be 0 or it can be 1. Okay, or it can be 1. So what is bitwise XOR? So bitwise XOR is something like, if the 2 bits are same. Okay, what is the first condition? If the bits are same. Okay, if bits are same. Okay, what you can get, the XOR result is going to be 0. Okay, similarly, if the bits are different. Okay, the XOR result is going to be 1. Okay, this is very simple. I'm explaining. For example, you have 2 bits. Let us say both the bits are 0, so the XOR result will be 0. If both the bits are 1, then again XOR result will be 0. If both bits are different, let us say first bit is 0, second bit is 1, or let us say first bit is 1 and like second bit is 0. In that case, the answer is going to be 1. Okay, so for our this particular problem, we only need to know this particular part. Okay, just go through this part, and this should be enough. I can say that. Okay, I've not kept a diagram for XOR operation, but yeah, you can just go through this particular part. I am sure that just Google out XOR, bitwise XOR, something like that. You will get multiple diagrams like that. Okay, and this is what you will be learning in that also. Okay? As simple as that. So now let us come to today's question. So see this part. Okay, we'll go by one by one. Okay, I've kept, see, there are going to be three cases in this. I've calculated all the three cases, and I've already inserted those cases in my test case samples. Okay, so I will be going through each of them. Let us quickly begin with that. So let us see the first case. Okay, 3 and 5. Okay, nums 1 is 3 and nums 2 is 5. So again, I am keeping these points here. Okay, so what we have to do, first of all, you have to get a number x whose number of bits are going to be same with that of num2. So this is our num2, and x XOR number should be minimum. Okay, first of all, let us get the binary representation of nums1 nums2. Okay, so remember, this is the case number 1. I will tell you what is case number 1, but say this part. So this is the binary representation of 3. This is the binary representation of 5. So case 1 is that when the number of bits in both num1 and num2 are same. Okay, this is going to be my case 1. So please take a pen and paper, or if you are really attentive, please keep noting what I'm saying. Case 1 is when number of bits in nums1 and nums2 are same. Okay, in this case, if you see number of, so yeah, this is what the binary representation will look like in Python. I'm using the bin operator. I will show you also like how I'm printing it. See this part. I'm just applying the bin operator to get the binary representation. It will give you a string. Okay, the string will have these two prefix always, so you can just ignore this part. Okay, you can ignore this part. Maybe I should have removed this part before printing it. Okay, that is fine. But yeah, this, after that, you're going to get the binary representation of the number. Okay, for 3, the binary representation is going to be like this, 1 and 1. Okay, this is going to be the, I can say, suffix. Okay, before that there will be all zeros. Okay, simple as that. Similarly, for 5, it is going to look like 101. Okay, now in this case, if you see, both of them are having two ones. Okay, so now what we have to do, we have to find a number whose, okay, who are that number should also have two set bits, that is two ones, and when we do XOR with num1, it should be minimal. Okay, so if you know XOR, like what I explained here, can you quickly tell me what should be the number now? See here, our aim is to make the XOR result minimal. So what is XOR? See, how to get a minimal XOR. See, if you want a minimal number, what should you do? Most of the bits should be zero. Do you agree with me? If you want a minimal number, what should you do, or what should you try to get? You have to get most of the bits should be zero. So how to get most of the bits zero? If we make same, okay, that is the two numbers that we are going to do XOR. If let us say both are having the same binary representation, then I can ensure that I am going to get the minimal number. Okay, I'm going to get the minimal number. And what is the minimal number possible? Minimal number possible is always zero. Remember that. Okay, so this is the case where we can get zero. Okay, can you quickly tell me how? See here. Now see this part, both of them are going to have say, two ones set. Okay, both 3 and 5 have two ones set. Okay, so now I need to find a number who which is going to have two ones set, and when I do XOR with nums1, I should get the minimum result. Okay, now can you tell me one thing? What if I XOR 3 with 3 itself? Okay, because 3 also has two bits set, right? 3 also has two bits set. So idea here is 3 is the answer, because if I do XOR of 3 with 3, I am going to get 0. Okay, so that is why 3 is the answer. 0 is the minimum possible number, that is 0 is minimal possible. For that reason, this is the case 1. Case 1 is when both num1 and num2 have the same number of set bits. Okay, always in such a case, what will be the answer? The answer will be num1 itself. Whatever is the num1, that itself is going to be the answer. Okay, this is the case number 1. Now let me show the case number 2. Case number 2 is when num2 is going to have more number of set bits compared to num1. Okay, so this is the case number 2. What is the case number 2? Number of set bits in num2 is going to be more than num1. So what will happen here, since x is also going to have same number of set bits as num2, so x is also going to have more number of bits than num1. Okay, as simple as that. So what we have to do, see, okay, here what you have to see is, I am sure that, see, number of set bits that the answer should have is going to be more. So obviously this scenario is not going to happen. That is, we cannot get exact same bit representation in order to make it zero. This is not going to be possible this time. Okay, because the set bits number is going to be different in the two. So what we can do is we can try to make the MSBs, that is, see here, the ones which are there towards the left. Okay, these are having a higher place value. Okay, are you getting me? See this part here, the number is 16. So if you see the place value of this particular one, it is 16. So if I can negate this, that is, if I can make this particular place value 0, that is the XOR result of this value. If I can make it 0, the rest of the values are going to obviously smaller. Okay, are you getting what I'm saying? The idea here is, when the since but I have more number of ones to apply. Okay, there are more number of ones in is going to be there in the answer. Okay, so one thing is very clear, I will try to negate the existing ones in my num1. See, this is the num1. Here wherever one is present, that one will always be retained in x also. Please check my point clearly. This is num1. Okay, here wherever 1 is there, I am going to have that place 1 in my X also. Okay, that's point number 1. Next is I have some extra ones. Those ones should be inserted in such a way that the XOR result is minimal. So how to ensure the XOR result is going to be minimal? We can insert the remaining ones in the LSB, that is the least significant bit, because the LSB is going to give the minimal answer possible. Okay, I am assuming that you are getting it. See what will happen. Okay, let me take this part and I will write it and show it to you. So this is the case number 2. See it here. See this part. Now this is going to, I am going to do XOR of this. Okay, let me write here XOR. I'm now going to do XOR of this with a number X. Okay, I'm going to do XOR with a number X. Okay, for now let us forget this part, because this is just going to tell me how many set bits are there. Okay, now I have to do XOR of this number. Okay, let me remove this also with a number X. Okay, now X is going to have 2 bits. Okay, now what I can do, see, first of all I will copy num1 as it is. Okay, this is the first trick. Wherever here 1 is present, I will copy here also 1. Next is that now I have one more bit to set. Where should I set? I have these places where I can set. Okay, among them I will choose the LSB. What is the LSB? This is going to be the LSB. Okay, sorry, okay, I have to put one to 0 also. Yeah, so this is going to be the LSB. Okay, so here I will keep a 1. I hope you are getting what I'm saying. See this part here, all are this like this, and here exactly same, but I'm just keeping the LSB as 1. So what will happen now when I do XOR? Can you quickly tell me what will happen? This and this will become 0. Rest all are anyway 0. Okay, rest are anyway 0. So XOR with 0 is also going to be 0, and only here the difference will come. Okay, so here it is 0, here it is 1. So the XOR result will be 1. So the answer of this is going to be, sorry, the XOR result is going to be 1, but we need this value. Okay, we need this value as the answer. Okay, so what is this value going to be? This is going to be, as you can see, just a bit is extra. Okay, let me show you this. So it is going to be 16 plus 1. Okay, the answer is going to be in this case 16 plus 1, because we have just one extra bit. So it is going to be 16 plus 1, which is the answer. Okay, as simple as that. Okay, so this is going to be an answer. Just you can take the decimal equivalent of this. This is going to be an answer. So this was the example number 2. Okay, let me quickly add it here. It is going to be your example number 2, or I can select test case number 2, because I guess I have taken some different test cases compared to what is given here. So this is the test case number 2. Okay, just for your convenience, right? Now coming to the third case. So see, what is the first case? I will again repeat. First case when number of bits in num1, num2 are same. Okay. Second case is when number of bits in num2 is more than number of bits in num1. Okay. And third case is when the reverse will happen. That is, number of bits in num1 is going to be much more than number of bits in num2. Okay. Here what will happen? See, here I have just 2 bits to set in my answer, but in nums1 there are going to be 4 bits. Okay, so this is such a case. Let me quickly take this also. I will quickly write it and show it to you. Okay, so now coming to, okay, test case number 3. See this part. So this will just tell me like how many bits are there going to be. Okay, so see, I'm going to do XOR of num1 with a number called X. Okay, now I have to get the minimal answer. Okay, the answer should be minimal. Okay, fine. So this will just tell me that in the X should have 2 bits set. Okay, so let me delete this now, right? So since X is going to have only 2 bits set, first of all, let me, okay, let me first put all zeros. Okay, now see this part. I want the XOR of this number and with a number X such that, okay, this is going to be number X such that I get a minimal result. Okay, for that what I have to do, first of all I have to remove the MSBs. Okay, the MSB should be targeted first. Okay, if I can, okay, negate these MSBs, that is, if I can make this value 0 in the result, I'm going to get a minimal result. Okay, so since I have just 2 bits to use, I will use those bits in the MSB. Okay, just like that. Okay, now see this part. I have 2 bits to set in the X. Now in the X I'm setting these bits, because in the numbers one also these bits are set. So what will happen in the result? See this part, these two values will be 0 in the result. Okay, just I will write the result also for you. See this part. See what is the first. See here it is also 1. Okay, here also it is 1. So what will happen? This and this will become 0. Okay, as simple as that. Similarly for the second bit also this will be 0, because here also it is 1 and here also it is 1. Okay, as simple as that. Now for the other two, this and this, it is going to be 1 and here it is 0. So bits are different, so result is going to be 1. Okay, so this is the minimum possible XOR result. Okay, so what are our answer is going to be? Our answer is going to be this. Okay, as simple as that. So it is going to 8 plus 4, which is 12. Okay, just see the answer. It is going to be 12. Okay, I hope you understood what is the, see, in case one, both of them are having same number of bits. In this case, whatever is the number one that you can have as the answer. Okay, as simple as that, and the XOR rate is going to be 0. Right? Case two, what it is here, the number of bits in num2 is going to be extra. Okay, so what we can have after setting this bit, we again are going to have a bit extra, so that we are going to set here. So it is going to be 16 plus 1, which is going to be the answer. Okay. In case three, what we had, see here the bits are less, so we should target the MSBs here. Okay, so we are going to target the MSB here. As simple as that, right? As much MSBs we can negate, that is we can reduce them to 0, that much bits we should try. Okay, that is what we are doing it here. So this is going to be test case 3, and this is the explanation for that. Okay, so yep, let us now quickly begin with the solution. See this part. First of all, I'm counting the number of set bits in both of them. Okay, so what I'm doing, I'm just calling the bin of the nums2. This will give me something like this. Okay, something like this will be given to me. Now here I'm going to count how many ones are there. Okay, that will tell me number of set bits. Okay, so the number of count of set bits in num2 is going to be bin of num2 dot count of 1. Okay, similarly count of set bits in num1 is going to be bin of num1 dot count of 1. Okay, as simple as that. Just this I'm printing for your purpose convenience. While you submit, please ensure you are commenting out the print statements. Otherwise, okay, you will be in trouble, because that will be affecting your time complexity by certain milliseconds. Okay, so ensure that you are just commenting out the statements. Next, I am declaring x. This is going to be my answer. Remember that our aim is also to find the x. Okay, x should be such that it is, when we are to XOR with a number, it should be minimal. Okay, the result should be minimal. First, this is the case number 1. What is the case number 1? Count of set bits in num2 when it is equal to count of set bits in num1. In that case, what is going to be the answer? The answer is going to be num1 itself. Okay, as simple as that. Like the case 1 we saw. Okay, coming to case 2. Count of set bits in num2 is greater than count of set bits in num1. That is, we have more number of bits than we require to make the result 0. Okay, as simple as that. So for that reason, what you have to do, first of all, whatever bits are there in num1, okay, whatever bits are there in num1, take them as it is to x. Okay, that is x equal to num1. Okay, whatever bits are set in, okay, let me see this case here. Okay, this is a test case. Okay, see this part here it is set. Okay, so I am setting this also. After that, we are going to add one more bit here in the LSB. Okay, that is what I'm going to do. See this part. First of all, whatever bits are set in num1, take them to x. Okay, so x equal to num1 now. Okay, whatever bits were set, now I have taken them to x. Next, I have certain extra bits to do. How many bits extra I have? See this part. Now I'm going to subtract these two. Okay, so count of set bits for num2, like, see, now this particular value is going to have the extra bits. Okay, because I'm subtracting this from number of bits in num1, right? This is now going to have the extra bits. Now this extra bits should be put in the LSBs wherever I find a place. Okay, remember, now this set bit should be inserted in LSBs. For that, what I'm doing, I am going to start from 0 till 30. Okay, before that, how we are getting 30? Okay, this part I should have done before, but anyway, see this part. They are saying that remember, if you are doing in Java and C++ or any other language, you should be very clear with how many bits you require. See this part, the highest value that can be get is 10 power 9. Okay, so for 10 power 9, we have to accommodate in n bits. Okay, whatever is the n, we'll get it now. So I'm just applying like this. So n square is equal to 10 power 9. Apply log on both sides. What we'll get, 9 log 10 is equal to n log 2. Okay, then what you have to do, take log to other side, that is log 10 divided by log 2. Okay, you are going to get 3.32, and then this 9 will come here. Okay, into 9. Okay, so this is going to be 29 point something. Okay, approx I'm taking as 30. So 30 bits, that is 0 to 29 bits, are enough for me to handle this much number. So in all my calculations, you will see that I am always keeping this in 30 range. Okay, that is 0 to 29 in this case, and when I do the reverse, it will be from 29 to 0. Okay, as simple as that. That's why always 30 is going to be enough for me, because that is the max result that I can have. Okay, because whatever with the input, I can handle it in 30 bits. Okay, so that is what I'm doing. I'm going from LSBs to MSB. Okay, wherever I find a bit which is not set. Okay, wherever I find a bit is not set, that I'm going to set. Okay, before that, what is this? So this is basically the right shift operator. So what is right shift? Let me show it to you here. Yeah, this is going to be the right shift operator. So what is happening? See this part. If you see the right shift, what is happening, the MSB, okay, like all the bits will shift by one particular position. Okay, how many times they're going to shift, that depends on the operator. Okay, in this case, I'm doing the right shift by I. Okay, so whatever is the I, that is my aim is, what is the ith bit in x, that should come to the zeroth place. Okay, whatever is the ith bit in x, that should come to the zeroth bit place. Okay, for that reason, what I'm doing, I'm doing a right shift by I. Okay, right shift works like this, just see it here. So the bits keep shifting to the right. Okay, as you can see, a new bit is inserted in the left, and all the bits keep shifting to the right. Okay, and the rightmost bit will be discarded. Okay, as simple as that. So the same thing I'm doing the x right shift by I. This will ensure that the x, that is ith bit in x, now it comes to the zeroth bit. Since it is now in the zeroth bit, I'm doing to do a and with 1. Okay, bitwise and with 1. So if the ith bit is 1 in x, okay, then the operation of this will be 1. If the ith bit is not 1, then if I do and with 1, it will be 0. So once I get 0, I know that the ith bit in x is not set. Okay, since it is not set, what I have to do, I have to set that bit. How to set that bit? I will do is, I will left shift 1 by I times and add that number to x. Okay, I will left shift 1 by I times. Okay, for example, let us say like this, you have 1, I am left shifting it by 2 places. Okay, so it will become like this, after one left shift, and sorry, yeah, after one left shift, and this is the second left shift. Okay, so this is how it is going to be. So its place value will keep changing. Okay, currently, well, let us see like that, this is 1. Once I left it by 2, sorry, a single unit, it will be becoming 2. If I left shift 1 more, it will be become 4 and 8 and so on. Okay, so what I'm doing is, see this part, I am left shifting 1 by this many bits. Okay, and left shifting 1 by I times, and then I'm adding it to my x. Okay, that is, I'm trying to set the ith bit here. Okay, okay, let me write it here. Okay, set the ith bit in x. Okay, that is for this purpose. Okay, as simple as that. right? Once that is done, I'm again like this is going to be my this will tell me how many bits are there to be set more. Okay, so I'm reducing this by one, this I'm decrementing it by one, and then I'm just checking whether it is zero. If it is zero, that means all the bits that I needed to set are already set. Just break out. Okay, as simple as that. So what I'm doing here, I'm finding whichever bit is not set. I'm going from LSB to MSB. Whichever bit is not set, make that bit as set. Okay, as simple as that. Okay. Yep. Because we want the answer to be minimal, for that reason we have to do it like this. Okay. Because we want the answer to be minimal, that's why whichever extra bits are there for me, I'm trying to set the LSB bits for that. Okay. Whichever the least significant bits which are unset, I'm trying to find them and I'm trying to set them. Okay. As simple as that. Now comes the third case. Third case is going to be very, very important. See this part. The third case is when, as we saw here in the case number two, the n nums2 we are having more set bits than nums1. What is the third case going to be? The third case is when the nums2 is going to have less number of bits compared to nums1. That is, nums1 is having more number of bits, but we have less number of bits. Okay, so case 3 was like that. Here if you see, there are more bits here in nums1, but we have less number of bits to set in x. Okay, as simple as that. So for the reason, what we have to do, see this part here, we cannot negate everything. Okay, let me zoom in. See this part here, there are more number of set bits in nums1. In x, we are going to have less number of set bits. So what we have to try, our aim should be to negate as many MSBs as possible. Okay, so in this case, if you see what we are trying to do, we are going to start from MSB. See, in case number two, we started from LSB towards MSB. Okay, now we will do the reverse. Okay, this time we'll go from MSB to LSB. Okay, as simple as that. So we are going to go from MSB to LSB. Now see here what we are doing. Same thing. Yes, if you see this, we did with X. Okay, the same thing we are going to do with nums1 now. Okay, I'm just finding whichever MSB bit is, that is highest bit is set in nums1, that should be negated first. Okay, in order to negate it, I have to add that in X. Okay, as simple as that. So I'm just making sure that with this. So what I'm doing, I'm right shifting the ith. So this will ensure that the ith bit is coming to the ones place. Okay, the zeroth bit place. Okay, once it comes, I'm doing and with one. So this, if this is true, okay, if this condition is true, that means that the ith bit is set in nums1. Since the ith bit is set in nums1, it has to be set in x also. Okay, so what we have to do, I'm just adding this number, that's I'm taking one, I'm left shifting it by I, and then I'm adding it to x. The idea is very simple. Please write it down. That's what I'm saying. Only then you will be able to understand it. See, if the ith bit is set in nums1, then the ith bit should be set in x also. Okay, that's what we are trying to do. I'm adding x to a number whose ith bit is set. This will ensure that x also has the ith bit set. Okay, because x will be zero initially. Okay, when we come to case 3, x will be zero. So we are trying to set that bit. Okay, as simple as that. Then since we have set a bit, I'm reducing this by one. Once it becomes zero, I'm breaking it out of the loop. Okay, as simple as that. So this was the solution. The first case is when both the numbers have the same number of bits. In that case, nums1 is going to be the answer. We don't have to do any calculation. Okay, case number one. Case two is when the nums2 is having more number of bits. Okay, that is, we have more number of bits to set compared to nums1. Okay, in that case, what you have to do, whatever is the number of bits are set in nums1, take it to x. Okay, as simple as that. Other than that, now what we have to ensure is, we have to ensure that the remaining bits go to the LSB. Okay, for that reason, we are going from LSB to MSB. Whichever is the not set bit, we are taking that and we are making it set. Remember, see the difference here. Here we are checking equal to 0. Here we are checking equal to 1. Okay, that is the difference. So what we are doing here, here we are finding whichever not bit is not set in X, take that and then set it. Okay, here what we are finding, here we are finding whichever bit is set, take that and add that, try to set that bit in X also. Okay, so this is the difference in both the cases. I am assuming that I have tried my best to explain you what is happening. Okay, but see, if you are not sure of this concept, I will say please pause the video. Okay, just Google what is XOR, what is left shift, what is right shift. Please Google it out. Or what I will say is, take this code, add some print statements, and just try to understand what is happening. Okay, then come and see this video. See, my aim is always that I give the max possible information in the video. I Yeah, but you can say that, okay, I'm not understanding what you're saying. I understand that, because see, in order to understand these things, you will be you should know some of the basics. So what I do is, I try to give as much hint as possible. See this part, you can go through this step. Okay, then try to understand what I'm trying to say. Okay, then come back and see this video. That will be helpful for you. Okay, this video, I agree that it's slightly in the higher level. If you're not aware what is the right shift, what is the left shift, and how these things are working, I'm sure that you will not be understanding. In order to solve this video, I'm assuming that, see, those who are following me from a long time, they would have known all this, because in the previous videos I've explained these things in detail. But if you're following me recently, then I'm sure that you will not be understanding this part. Okay, but since this question is not that difficult, please take a moment to go do a Google search, understand these stuffs, like what is left shift, how it is written like this, and why you are left shifting it by one, and all those things. Just understand it by once, then come back and see this question. then see this answer. Okay, what I'll say is take this answer, add some print statements, just try to understand what is happening. That will also give you some idea. Okay, as simple as that. But since this question is on XOR, you should know these basic things, like what is left shift, what is right shift, when we do a AND operator bitwise, what happens to the remaining bits, and all the things should be very important. Okay, as we see, we are doing a AND with 1 and we are checking it to 0. What it means, see, idea is very simple. What I'm doing is the ith bit in X. Okay, I am trying to begin to the 0th bit. Okay, and 1 is also there in the 0th bit. Now I'm doing a 1 with this. So what this will tell me, if it is 0, this will tell me that the ith bit is not set in X. Okay, this will tell me that. Okay, since the ith bit is not set in X, we are trying to set it. Okay, this is the case here. But if you see what we are doing here, in this case, what I'm trying to check is whether in num1 the ith bit is set or not. Okay, this is what we're trying to check in this. If the ith bit is set to 1, then what I'm doing is I'm setting it in X also. Okay, as simple as that. So yep, there is slight some of the topics you should know already in order to understand this level of complexity. Okay, as simple as that. So yeah, friend, that was all for this video. This okay solution is beating 100% of the test cases. Please go through it. I felt like I'm always trying to give you the best, but still, if you're not able to understand, please do comment below. Maybe I can provide some more resources for you to go through it and learn. Okay, remember, everything cannot be taught in a single video, especially in topics like bit manipulation. It is a very vast topic, so do a bit of homework, then come and see this video. This video is actually, I can say, for not for beginners. I can say that, yeah, this is slightly for those who have done some questions at least on bit manipulation. Okay, so do some questions and then come back and then see this video. I'm sure you will be able to understand whatever I explained. Please believe me, that makes sense. Okay, if you're not able to understand this part, then you'll have to do some homework. Okay, but what I try is, those who somewhat, at least they will be able to get the most of my video. That is what I am trying to aim at. Okay, if you're not able to understand, please do some homework, then come back and see. Okay, but what I'm sure that whatever I'm explaining, I am giving every detail of what I'm doing. So once you understand what is happening, then if you come back and see, you will get all the reasons, all the explanations for your doubts. Okay, yeah, and that was all for this video. If you like my efforts, please subscribe to the channel. This really gives us a lot of motivation to continue further. And yep, this was my 85th day of video, or like 85th consecutive day of uploading the video. And one more thing is, if you talk about space and time complexity, see this part. Since, see this case, it depends on the case, basically which case we are at. Time complexity will depend on that. But yeah, overall what we are doing, see this part, either if we are in this particular case, we are having a for loop of which runs 30 iterations. And similarly, in this particular case, we have a for loop which runs 30 iterations. So since these iterations are not dependent on n, okay, these are not dependent on n, according to me, this is going to be a O of constant solution in terms of time complexity. In terms of space complexity, okay, let me go through what is the space complexity going to be. Again, it should be a constant space complexity, because if we are calculating x is just a requirement of the question. That is point number one. Second thing is that, yeah, we are calculating these stuffs also when we are doing addition. But again, remember the number. Okay, this again, after going to a number, it's not going to be unlimited string. Okay, we are just going to have a number that is a number which has 30 bits at most. Okay, so yeah, so it should be constant according to me. This should not matter. It is not going to be dependent on the value of this. Okay, so whatever is the highest value of that, we are already taking that, and the number of iterations will not vary. That is, it will not increase or decrease based on these values. Okay, because already I'm taking the max limit and I'm doing the 30. Okay, I'm getting 30. I'm getting 30 from here. So my request to you will be, please see this calculation. Always do this calculation whenever you get these questions in a face-to-face interview. Okay, this will make more sense, because what will happen if you don't do these calculations, you will never know what is how many bits you require. Okay, let us say number is smaller and you can just need 15 bits. So instead of 15 bits, you are taking 31 bits and doing it, and you are getting time limit exceeded. That is the worst case that can happen in interview. Okay, so always do this kind of calculations, learn this kind of maths, and then do it. I'm sure that you will be able to impress the interviewer. Okay, if you show this kind of stuffs, and yeah, if you code this kind of solutions, I'm damn sure you will be selected if this question comes in the interview. Okay, this is a very good question. I can expect this kind of questions in a FANG level interview. But remember, if this comes, you should be giving all proper explanations, and then you should be reaching the solution. Okay, if you do that, I'm sure you will get selected, because see here, we are doing the optimal approach. Okay, this is the most optimal thing that we can do. Okay, we have not compromised on anything here. This is the most optimal way possible. Remember that. Here we are not assuming anything or something like that, or there is even more optimal approach possible, nothing like that. This is the most optimal approach that is possible, because we have done all the calculations and we are doing everything straight. Okay, we are not doing anything which is not optimal. Okay, assume that we are not assuming that, okay, let us take only 30 bits, let that be enough. We are not assuming that. We have proper calculations to prove that. Okay, so yeah, friend, that was all for this video. If you like my efforts, please subscribe to the channel. This really gives us a motivation to continue further. If you want this video in Hindi, please do let me know. Please do comment below. I can again upload Hindi video for this, but yeah, it is getting very late today. So yeah, I am, because I've already spent so much time here, I am assuming that this video again will be helpful to you. But yeah, if you want in Hindi, please do comment below. I will need some time and then I will upload the Hindi video if you need it. See you tomorrow. Thanks a lot.